Module 9, Lesson 1 covers the circumference of circles. Circumference, you should know by now, is going to be the distance around the circle. The pacing guide claims this is going to be a 2-day lesson. We have 16 resources to go through, so that's probably going to be fairly accurate. Let's see what they actually say here. We're going to start off with an infographic which says, who wants some pie? And no, we're not talking about deep dish apple walnut pie or my favorite pecan pie. We're talking about the Greek symbol pi that was established by some dead Greek guy. Pi is defined as a constant mathematical value that is represented by the Greek letter pi. It is the ratio between the distance around a circle and its diameter. Pi is special because it never terminates. It's what we call an irrational number. It never terminates and it never repeats. It goes on and on forever throughout all time and eternity. Each year I generally do a challenge with my advanced math students where they can get a bonus quiz just for memorizing the first 50 digits of pi. Right? Yep, that's hard to do. Computers have calculated pi to the 12 trillionth digits, and I know that there are people out there who've actually memorized pi to the 100,000th decimal place. Like they don't have anything better to do with their life. I mean, really. A brief history of pi started somewhere between 1900 and 1680 BC when the ancient Babylonians used triangles to estimate what the value of pi would be. And then in 1650 BC, the Egyptians used squares to estimate the value of pi, and they got pretty close, estimating it to be 3.16049. Then in the 3rd century, the Greeks got in the game, and the mathematician named Archimedes, the famous dead Greek guy, approximated the value of pi to be between 3 and 10 over 71 and 3 and 1 over 7. Moving along, 5th century, Chinese astronomer Zhu Chongzi estimated a fractional value of pi to be 3 and 16 over 113. I know this means absolutely nothing to you. And then in AD 1737, Swiss mathematician Leonard Euler popularized the use of the symbol pi. So you would think the dead Greek guys made use of that symbol since it's their language, but no, in fact it is not the Greeks who named it pi. It was Leonard Euler. While the first concept of pi has been around for 4,000 years, the symbol itself has only been around for 300 years. Because the first 3 digits of pi are going to be 3.14, March 14th, 314 has been recognized as Pi Day. Incidentally, Albert Einstein, the famous American mathematician, was born on Pi Day, March 14th in 1879, and pi has been cited as the most recognized mathematical constant. I guess they got a blue ribbon for that or something. When calculating pi, you need to use the pi symbol, which is this little Greek thing right here, to show the exact answer. For example, the distance around a circular garden is going to be 3 pi, not 3 times 3.14 and whatever answer you get, because that's not precise. It's not precise because pi is an irrational number. It never stops moving. But that doesn't help if we need to know how much fencing we need to buy. So if we need to know how much fencing we need to buy, then it's time to estimate pi down to 3.14. So the distance around this circle here would be about 9.2 feet, and that's how much fence we need to buy. Our inquiry question this lesson asks, how does the distance around a circle relate to its diameter? Let's use a web sketch pad to find out. In this sketch, D represents the diameter, while C represents the circumference of the circle. The plotted point D and C in the model, the relationship between the diameter and the distance of the circle. We're going to press animate diameter and see what happens to the graph as the circle changes. Record your observations and press a button again and to stop the animation. Alright, so we're going to animate our image here. Let's scroll it down. So we're going to take and go boom, and you can see that it does not matter how big the circle is, you get a linear relationship, meaning that the relationship between the diameter and the circumference of the circle is always going to be constant. And what's that constant going to be? That constant is going to be 3.14. Because if we could get this to be exactly, let's see if I can make that work. Nope, it won't allow me to move it to 3.1 to 1. But if we had a diameter of exactly 1, the circumference would be exactly 3.14, yada, yada, yada. So not so exact after all. So here we can take and actually do what I was talking about, setting the diameter to 1. And when we set the diameter to 1, what did the circumference equal? The circumference equaled 3.14. So we can see there is that, once again, that constant relationship, that linear relationship. When the diameter is 1, your circumference is 3.14, also known as pi. And it's time for some definitions. The first of which is a circle, which is a set of all points on a plane, not the kind you fly in the sky, but a flat surface, is what a plane is defined as. A set of all points on a plane that are the same distance from a point called the center. And we're going to take and highlight that all green, but then we also have to take and highlight or define the center, which we'll see in a minute. The diameter is going to be the distance across the circle through its center. We're going to highlight that. And then the radius is going to be the distance from the center point to any point on the side of the circle. So if we take a look here, the center, that one is going to be this spot because that line points directly to the center. This line right here points to the radius, and this line over here, it points to the diameter, the distance all the way across the circle. Now, because the radius of the circle is the distance from the center to any point on the circle, and the diameter is always going to be twice the radius, that means the radius is going to be half the diameter. So you have two formulas you can see down here. The first one says the diameter is equal to 2 radiuses. The second one says the radius is equal to 1/2 the diameter. You may find these useful as we continue in this study. Continuing with learning our definitions, we have circumference. Circumference is defined as the distance around a circle, and the circumference of the circle is proportional to its diameter, as we discussed in that line graph we looked at earlier. The exact ratio of the circumference divided by the diameter is going to be represented by the Greek symbol pi, so that's going to be another vocabulary term right here. And then that value is, of course, this right here, but it keeps going on forever. The decimal never ends, but it's going to be approximated as 3.14. Another approximation for pi is 22/7 as a fraction, but that's not nearly as close as 3.14 is. Now we're going to select some cards to learn what happens. So first off, in words, to find the circumference of a circle, we're going to multiply pi by its diameter, or pi by 2 times its radius. With symbols, we could say that circumference is equal to pi times the diameter, or circumference is equal to 2 times pi times the radius. And then actually modeling it, we could see that the circumference, your pink line here, is going to be, you've got your diameter here, so it's either going to be 2 times pi times the radius, or it's going to be pi times the entire diameter. So how close do you think 22/7 is going to be to the actual value of pi? Let's find out. I've got my calculator. Right there is a value for pi, and then I'm going to use another calculator. And on this one, I'm going to divide 22 by 7. Sorry, my class is getting rowdy. And you can see that we lose it at the third decimal space, 2. For example 1, the question asks us to find the diameter, to find the circumference with a given diameter. Big Ben, big old clock in England, is a famous clock tower of London, England. Kind of said that, didn't it? The diameter of the clock face is 23 feet, as you can see in the image here. The diameter of the straight line across, 23 feet. And it says find the circumference of the clock face, use 3.14 for pi, and round your answer to the nearest hundredth if necessary. So from there, we're going to move forward, and you can see what they did. They took and started off by making an estimate, and making their estimate, they said, right here, they just rounded pi to be 3 instead of 3.14. And then they said 3 times 25. They rounded that 23 to 25. And that gave them an estimate of 25 feet. That is, to me, an estimate of 75 feet right here that you see here. That's a good thing to always do on these problems because it lets you know if you're in the ballpark when you start getting into the more nuts and bolts of multiplying decimals. Moving down from here, you can see the original problem. They use the formula first. You have to write the formula. It's the first thing on every problem of your homework. So circumference is equal to pi times diameter. You could also use 2 pi radius if they gave you that instead of the diameter. Next, we're going to say circumference is equal to pi times the diameter of the clock was 23. They flipped that around to be 23 times pi. I don't see any good reason to do that. And then they changed pi to be 23 times 3.14. I don't see any good reason to do that either. If it was me doing it, I would, on the second line, said circumference is equal to 3.14 times 23. Multiply that out to get to the 72.22 feet to the nearest hundredth. 72.22, therefore, is going to be our final answer. Check it. Get rid of the third and the fourth, give me the second and the third line. I don't care about seeing them, but lines 1, 4, and 5, that's going to be the supporting work you're going to need to see in your homework. Now the textbook is pointing out here that the formula changed. It went from being an equal sign to an about sign when they went from pi to 3.14. Now it's going to be your turn. Stop the video and do extra example 1 on your own where you're finding the length of a circular fence, also known as the circumference, if it's going around a garden that has a diameter of 10 2/3 feet. That's going to require multiplying some fractions in here. I don't really like fractions and decimals getting together, but that's what they want you to do. See what you can accomplish. As a hint, if it was me working it, since I have a decimal right here, I would change that 10 2/3 feet to the decimal version of 10.66, repeating. So how did that go for you? I'm going to go ahead and work it 2 here. And I'm going to start off by writing my formula. Formula is always the first thing you write. And the formula says circumference is equal to pi times diameter. So circumference is equal to 3.14. And like I said, I'm going to change that 10 2/3 to be 10.66. From here, I'm going to come off to the side and do my grunt work. It doesn't matter which one's on top, so I'm going to put the bigger number on top just to make my multiplication a little easier. 4 times 6 is 24. 4 times 6 is 24, plus 2 is 26. 4 times 0 is 0, and 4 times 1 is 4. Next line, skip over 1. 1 times 6 is 6. 1 times 6 is 6. 1 times 0 is 0. 1 times 1 is 1. And the next line, skip over 1 again. 3 times 6 is 18. 3 times 6 is 18, plus 1 is 19. 3 times 0 is 0, plus 1 from the 19, and then 3 times 1 is 3. Now I think I may have made a mistake back here. Yep, this one, that 0 right there, I believe that is supposed to be a 2. So let me fix that. I'm going to add all these numbers up. 4, 12, carry the 1. Then I'm going to have 17, carry the 1. 14, carry the 1. 3 and 3. Bounce 1, 2, 3, 4. 1, 2, 3, 4. I believe it said to round to the nearest hundredth. So if it's a hundredth, our answer is going to be 33.47. Let's jump back over here to our textbook. It says, yep, 33.47. Check. And why is it saying it's wrong? They may have worked it more as a fractional version, but just real quick, check my math. My math is good. As you can see here, the difference between their answer and my answer comes down to the fact that they did something different with the fraction in there than I did. I have no issue with the answer I got, though. We're going to end part 1 of this video right here. Come back and watch part 2 in a little bit, where we're going to continue our study of circumference. Only this time, they're going to give us a circumference, or find the circumference using a radius instead of a diameter.